Should we start? Okay. So in the first lecture on Unit 2, that is Embedded Systems for IoT, we have already started with what is system, what is embedded system, what is Internet of Things. Then we have seen that the characteristics of the embedded system. We have also seen types of embedded systems. Depending upon the functionality, embedded systems are divided into various types. Depending upon the use of microcontroller or microprocessor, they are divided into three types. So in this way, we have seen that embedded systems are having some of the advantages. They are also having some disadvantages. We have seen examples of the embedded system. We have also seen the applications of the embedded systems. Now we'll be moving forward. Today we'll be seeing the components of embedded systems, and then we'll move towards the different components of embedded systems, how they work out to be. So let us begin with the first slide. Once again, I'll repeat that slide because you must know the background of this unit. You must know what is actually we learning for. A system is an arrangement in which all the units are assembled together and they run according to the set of rules. An embedded is nothing but one thing attached with the other thing. Embedded system can be thought of as a computer hardware with software embedded in it. Internet of Things is nothing but the network of physical objects or person or idea called as things that are embedded with software, electronics, network and sensors, and that allow these objects to collect and exchange the data. So the last line is very important, is to collect and exchange the data. So this is possible when many devices will talk to each other, and that is called as the IoT. And when IoT will combine with embedded systems, it will become a very nice application development is possible. So now we'll move towards the next concept in this unit, that is different components of embedded systems. Basically, there are three components of embedded systems. I could say that there are only two. One is your application software and the next one is a platform. Under platform, you do have hardware and software. So वैसे देखा जाए तो ये दो ही components है, हार्डवेयर और सॉफ्टवेयर. लेकिन अगर हम प्लेटफॉर्म बेस पे काम करें तो एप्लीकेशन सॉफ्टवेयर एक चीज़ है और प्लेटफॉर्म के अंदर हार्डवेयर और सॉफ्टवेयर एक चीज़ है और साथ ही में रियल टाइम ऑपरेटिंग सिस्टम भी एक चीज़ है. सो इस तरह से हम इसे दो कंपोनेंट्स या फिर थ्री कंपोनेंट्स भी लिख सकते हैं. यू कैन राइट इन एनी वे, नो प्रॉब्लम एट ऑल. So now what is hardware? The hardware may be sensors, it may be ADC, it may be processors or ASICs, it may be DAC, actuators, etc. And the software may be a bootloader, operating system, and the system program. So we will see one by one what are the hardware components and what are software components. Now let us start with the hardware components of embedded system. The first one is the power supply. For the embedded system, the power supply is the key components to provide the power to the embedded system. So in the range of 1.88 to 3.3 volt is a usable voltage range, as 5 volt supply is required, but 1.8 to 3.2 volt is possibly accepted. The power supply source can be a battery or it may be provided by an adapter. Then second hardware components is a processor. So we know that the processor is responsibly the deciding factor for the performance of the embedded system. As we have seen the types of embedded systems in which microcontroller based types, we have seen that small, medium and sophisticated. So we have seen the range of the processors that can be used for the embedded. So in this way, 8-bit, 16-bit or 32-bit processor can be used. The lesser the bit, the smaller the application is for the embedded system. So we can see that the more bit processor can be. Nowadays, users are migrating from 8 to 16-bit and 16-bit to 32-bit microprocessors. So the lesser the bit will be used of the processor, lesser will be the smaller will be the application. The next part of the hardware components is memory. It is a very crucial part as data is stored temporarily in RAM, and the ROM is useful for storing the program, and when the system is switched on, the embedded system fetch code from ROM memory. So mostly your program is been stored in read-only memory, and then from where it embedded system fetches the code from that memory. Then for these timers and counters, this is also a very important hardware component. In some of the applications, there is always a requirement of delay needed to provide in the application. So for example, in LED display application, there is requirement of some delay so that LED can be continued blinking. So let us take an example of LED blinking after some seconds, on off, on off. So in that way, the timer and counter can be used in the embedded system. The program can be done such a way that delay can be generated in the embedded system. The delay span can be decided using crystal oscillator and system frequency, so that delay can be generated as per the requirement. So mostly what is happening is that their delay is required in the programs, and in order to provide that delay, timers and counters can be mostly used. The delay time span can be decided by using crystal clock frequency, that is crystal oscillator, and through that you can give the delay as per the requirement. Then next will be the communication port. Obviously, all this hardware components we have seen, but this port is also a very crucial port in order to study. It's a communication port. The communication port is the type of interface that is used to communicate with other types of embedded systems. So we can say that there are a lot of embedded systems working around. So there is a large embedded system in which there are small embedded systems that are work out. So now the communication port will help you to interface and communicate with the other types of embedded systems. In the embedded systems, there is multiple types of communication ports like UART, USB, Ethernet, RS485, and many more. RS232 and RS485 are used as serial communication. RS485 is useful for longer distance as compared to RS232, which is useful for smaller distance. When an embedded system is used in a small scale applications, then communication port can be used from the microcontroller. There are also serial protocols that can be used for sending data from one system board to another board. Then comes the output and input part. So what input are you giving and what are the outputs that is been taken out from the system? When the embedded system is used, the input is needed to interact with the system. The input to the embedded system can be provided by the sensor or by the user itself. The processor used in the embedded system can be based on input and output. So depending upon what the input and what output is, you can decide your processor, right? And the type of processor you decide, then the type of embedded systems you can decide. So they are all interrelated with each other. So based on input and output, the processor is selected, and based on types of embedded system, the processor is selected. So in this way, you can select output and input. The proper configuration needs to be done for using the input and output port. In the embedded system, there are fixed input and output ports so that devices can be connected to the specified ports only. For example, P0, P1, and P2, and many more. So depending upon that, the processor can be selected, and depending upon input and output, the ports can be also selected. Specified ports you can select. Then the next component is the circuits used in the application. When the embedded system is designed, there are several hardware components that can be useful for design purpose. The selection of the circuit is completely dependent on application used for the embedded system. So the circuit designing part is totally depending upon the application that is being used for the embedded system. For example, we can take temperature sensor application. There is requirement of temperature sensor for measuring the temperature. So depending upon which kind of temperature sensor you are using, the circuits can be inbuilt in that. For example, temperature sensor, then you are going to measure the temperature. So according to that, circuit is used in the application. In the other applications, you can use various different sensors and the circuits that are related with the sensors. When all the hardware components are selected for an embedded system, the next task is to select software components for designing an embedded system. So up till now, we have seen the hardware parts like power supply, processor, memory, timer, counter, communication port, output and input, and circuits that are used in application. Now comes the software components of the embedded system. Now the first software component is the assembler. Now this is the very crucial point to understand these things, because while doing the practicals, you're going to be you have to go through these software components. The first one is the assembler. The assembler is used when programming language used for designing the application is assembly language. So obviously assembly language, when it is used, you have to use the assembler. The assembly language program is then converted into the hex codes so that it can be further processed. And after writing the code, the programmer is used for writing the program in the chip. So assembler is used when the assembly language is used. The assembly language program will be converted into the hex code for the further processing. And after writing that code, the programmer is used for writing the program in the chip. So this is how the assembler works out. Then emulator. An emulator is a software tool that is used to execute the function of the host system. So emulator software tool is used to execute the function of the host system, means the system which has been working and to which all the other systems are connected. All the components can be controlled by the emulator tool. So all the components that are on the circuit board, they can be controlled by the emulator tool. The emulator is also used for finding the bugs and debugging code. This is the most important function of an emulator, that can be used for debugging. So you can find out the errors in your program code. The emulator also used to transfer the code from host system to the target system. So I have already said that the emulator is used to execute the function of the host system. So it can also be used to transfer the code from the host system to the target system or to the destination system where you're going to transfer the code. So for that purpose, emulator is used. Assembler is used to write the program in assembly language, which is converted into hex code, and then it is written, and then the program is written in the chip. But emulator is actually used to execute the function of the host system, and all the components can be controlled by the emulator, whereas emulator can be used as a debugger, and it can be used to transfer the code from host system to the target system. So these are the two software components that are used. Then the third one is a compiler. Obviously this you know better. The compiler is a type of software that is used to convert the programming language into some language which is understood by the target machine, that the target machine can understand and execute the function. The basic use of the compiler is to transfer the high level code into some low level code languages. The low level language includes machine code, object code, and assembly language. So clear cut, what compiler is, that it is used to convert the programming language into some language that the target machine can understand. Okay. The basic use of the compiler is to transfer actually the high level code into some low level code, and these low level languages are nothing but the machine code, the object code, and the assembly language. Now next part will be the after hardware and software is the operating system. Now before moving to understand the real-time operating system, I do feel so we should first understand what the operating system does. An operating system is nothing but a collection of software that manages the computer hardware resources and provides common service for the computer program. So it is a collection of the software that manages the computer hardware. The OS is a vital component of the system software in the computer system. The OS is an interface between computer user and hardware. This is a very important line. It is an interface between computer and the user. An operating system is a software which performs all basic tasks like file management, memory management, process management, handling input and output, controlling peripheral devices such as disk drives and printers. So this is to perform the following tasks. The OS performs so many of tasks that are very important, it manages also the computer hardware resources. Some popular operating systems include Linux operating system, Windows operating system, then VMS, OS 400, AIX, ZOS, etc. So some of the operating systems are mentioned here. Now these are some of the important functions of operating system. I've already told you, but I have listed it out, like memory management, processor management, device management, file management, then security, control over system performance, job accounting, then error detecting aids, and coordination between other softwares and users. So these are some of the functions of OS. Now we'll move towards the real-time operating system. Now there is always a question that whether RTOS is better than OS or OS is better than RTOS. You'll get the answer for that question also. So let us first of all understand a real-time operating system. What is the difference between the operation of real-time and the normal OS system? Now a real-time operating system, commonly known as a real-time operating system, is actually a software component that rapidly switches between the tasks, giving the impression that multiple programs are executed at the same time on a single processing core. Its simple example is that let us assume that you're blinking your eyes, and you're blinking your eyes in such a way that you're shifting your eyes so fast that it appears like only one task is carried out, like multiple programs are being executed at the same time, but it switches between the task in such a way that it gives an impression that a lot of programs are running at the same time, but it doesn't happen. It doesn't mean that. It means that it is executing only one program after the other program. It is executing one after the other program, but due to the fast switching between the tasks, the impression is that it is executing multiple programs. That is what the advantages of real-time operating system is. In actual fact, the processing core can only execute one program at one time, and what the RTOS is actually doing is rapidly switching between the individual programs or threads. So what we said to be a thread is also called as a task. So it switches between the task in so fast that it looks like as if multiple programs have been executed. But I'll tell you, it executes only one program at one time. So on a single processing core at the same time. RTOS supervises the application software and provides the mechanism to let the processor run a process as per scheduling by following plan to control the latency. So that means it is having the mechanism to let processor run a process as per the scheduling by following the plan. So there is a plan of executing the task and the task run as per the scheduling. Now, this is the very important concept now to understand why the RTOS or why the OS should be preferred. That is the thing we are going to look in this slide. Now, the real-time operating system defines the way the system works. So obviously it is related with the system, as the name suggests, operating system. So it defines the way system works. It sets the rule during the execution of application problem. A small scale embedded system may not have RTOS. So obviously this RTOS is used in medium scale or in a sophisticated scale embedded system. Now if you look at the difference between OS and RTOS, we'll come to know that OS actually provides a non-deterministic soft real-time response. In this, you remember this word soft real-time response, where there is no guarantee as to which task will complete, but they will try to respond responsive to the user. So whatever the task that is been given by the user, it will execute it. But suddenly, if the other task comes and the priority is given to that task, then it will go to that task, leaving the earlier task. This is what the operating system does, because it has to give response to the user's call. But in case of real-time operating system, it provides a hard real-time response, providing a fast, highly deterministic response to the external events. So what is happening is that in case of real-time operating systems, they prefer to give attention, most attention. In this way, they may not give attention to the new task. But in real-time operating system, they have to give attention to the new task, that is external event. एक नया टास्क दिया तो उसकी तरफ ज्यादा ध्यान देना पड़ेगा. ये लोग उस पहले वाले टास्क को कंप्लीट करके दूसरे वाले टास्क की तरफ जाते हैं. सो अकॉर्डिंग टू द प्रायोरिटी इट कैन go to the external event that is suggested by the user. And second most important difference is that in operating system, the scheduling algorithms are round robin, cooperative or hybrid scheduling. So in case of operating system, the priority of scheduling the algorithm is an in a is it may be robin, cooperative or hybrid scheduling. These are the types of scheduling that is followed by the OS. But in case of real-time operating system, there is only one scheduling, and that is priority. So the user, if suggested that a new task is having more priority than the previous task, then the real-time operating system will go to the new task scheduling. So these are the differences between OS and RTOS. So I do feel so RTOS is having some advantages because of the shifting between the tasks, because of the fast switching between the tasks, and that's why RTOS is very, I could say, having more advantages than normal operating system. Then next will be why use real-time operating system. So I've already gave you the difference between the operating system and real-time operating systems. But in this case, I'll be also detailing about some of the points which can be a conclusive point about using RTOS, and these are the reasons why used for RTOS. The first is the priority based scheduling. So now only I have explained that it gives the priority. Uh, the scheduling is according to the priority. If the user says the new task is his first priority, so the first task will be left alone, and the next task, which is having a higher priority, will be scheduled. Second is abstracting timing information. The RTOS is responsible for timing and provides API function. This allows a cleaner and smaller application code. So it is like an abstract means what, like we'll take an example of having a 12 length paper, 12 pages length paper, and all the explanation is in the summarized abstraction is in the abstract of the whole paper, which is being cited. So in that way, the abstraction is calculated out. So the application code will be smaller. So this is the second most point that RTOS to be used. Third is maintainability and extensibility. Abstracting timing dependency and task-based design results in fewer interdependency between the modules. So this makes an easier maintenance. See what happens in operating system if we see that one of the things is dependent on the other things. So if you want to calculate, if you want to go for one task, it is dependent on the other task. But in this case, what is happening, the different modules that, or different tasks that is been carried out, there are very less interdependency between the modules. So this makes the maintenance quite easier, because if one has to be maintained that is dependent on the other, it will create a little bit of havoc in between how to manage how to manage all the things. But as these internal modules are interdependent on each other, a separate ECM, a separate maintenance can be done for each task, and that's why the overall maintenance becomes very easier. Then next is modularity. The task based on API naturally encourages modular development, as a task will typically have clear defined role. So for each of the tasks, there is a clear defined role is there. Means if this task is to be done, then there is a role to carry out that task in case of real-time operating system. It promotes the team development. The task-based system allows separate designers, oblique teams, to work independently on their part of the project. So there is the task-based system allows the separate designers to work independently on their parts. As you know that all the suppose there are 5 parts in one task. Now these all 5 parts are in one task are executed separately. So what is happening is that the designer can independently work on each of the module of the task. They don't have to be dependent on the other module of the task. So it's very clear, simple that this is one task. These are 5 modules in that task, and the first module to be executed by the designer. Second module is executing by the other designers, so they can individually design, and then after that it will be fully final. So the dependency on each of the module is avoided, and that's why the team development can be easily work independently on their parts of the project. So different parts of the project, you can work individually on this part, second part, third part, fourth part, in that way. Then the easier testing. Modular task based development allows the modular task based testing. So obviously if the each and individual part of that whole program is worked out separately, that means the testing can also be done separately. There is no need that you're depending on this task because that task is dependent on the other task. It doesn't happen like that, so the testing becomes quite easier. Then the next point is the code reuse. Another benefit of modularity is that similar applications on similar platforms will inevitably lead to development of library of standard tasks. So the code can be reused very easily because as the library of the standard task is defined, and that will help to the reuse of the code. Then improved efficiency, and RTOS can entirely be event driven. No processing time is wasted polling for events that have not occurred. So the task that has been given has been completely focused on that task, and that task is completed. So it's an event driven. This is very important line of an RTOS, can be entirely event driven. Then the ideal processing. So background or the ideal processing is performed in the ideal task. This ensures that the things such as CPU load measurement, background CRC checking, etc. will not affect the main processing. So as the all modules are totally independent, so they will be not affecting the main processing, and hence it's an ideal processing. So in this way, we can say that the real-time operating system can be used over operating system, and when a medium or the sophisticated type of embedded systems can use real-time operating system, whereas in case of small embedded systems, I don't feel so RTOS is necessary, as it is an standalone kind of a system which can run through self applications, and that's why the real-time operating system is not needed there. But in case of medium and sophisticated, it can be used. So I'll revise a little bit of points from initial. So this is the three components: hardware, software, and RTOS. Then the hardware parts are components are power supply, processor, then memory, timers and counters, communication port, then output and input, then circuit used in the application. So it depends upon which kind of sensor are you using. For example, a temperature sensor is used, then the circuit accordingly can be used. If it is a moisture sensor, then accordingly the moisture sensor circuits can be used. Then uh, the software components of the embedded system. So it is an assembler. So assembler is used when you're writing the program in assembly language, which is then converted into the hex code, and then it's written in the program in the chip. Then emulator is a software tool that is used to execute the function of the host system. It can also control all the components. Then it can be used to find bugs or like debugging code, and the emulator can be used to transfer the code from the host system to the target system. So that is what the emulator is, and compiler is used to convert the programming language into some language that is understood by the targeted machine. And basically we are converting into high level code to the low level code, or high level language to low level language. Coding is done, and the low level language includes the machine code, object code, and the assembly language. Then we have seen the operating system. So the main functions of the operating systems are memory management, processor management, then device management, file management, security, control over system performance, job accounting, error detecting, coordination between the other softwares and users. And this is the real-time operating system. So I've already given you that it said that it rapidly switches between the tasks, giving an impression that multiple programs are being executed at the same time on a single processing core. But that is not the case. It carries out each individual task, but the shifting is so fast that it looks like multiple tasks is being carried out. Then RTOS provides a mechanism to let the processor run as per the scheduling of by following the plan. So the difference between real-time operating system and OS is that there is no guarantee as to which task will be completed, but they will try to be responsive. But in real-time tasking, according to the priority base, the task will be completed. So scheduling may be round robin, cooperative, and hybrid scheduling, whereas in this case, it's a priority based scheduling. Then why use real-time operating systems? So priority based scheduling, abstract timing information, maintainability, extensibility, modularity, promotes team development, easier testing, code reuse, improved efficiency, and ideal processing are some of the points that really gives real-time operating system a thumb up. So these are the points that we have covered. So have you got this? Hello? Hello? Hello?